Hi all. So you've all heard the old joke about the Christmas lights, right? The Christmas lights where one light goes out and the whole string goes out. That actually is a really good example of a series circuit, right? In a series circuit, there is only one path for current to flow. So if one element opens up, there's no way the current can flow in the circuit anymore, and current stops flowing. Because there's only one path for current to flow, the current is the same throughout the entire circuit. So how do you solve a series circuit? Well, schematically, right, a series circuit looks like this. One of the visuals I always like to give is if you actually could shrink down and get into an electron car, right? So if you were in your electron car, you could start at the battery and you could go up through the first element, the second, the third, the fourth, and then you're back at the battery. Right, so there's only one way you can see for current to flow, series circuit. The way to go about solving a series circuit is pretty simple. First you take and you solve for the total resistance. Right? The total resistance in a series circuit is simply the sum of the resistors. Say add all the resistors together. Add the values for each of the resistors, get the total resistance. Once you have the total resistance, it all becomes an Ohm's law game. Right? So we know that the current is the same throughout the circuit, so all the currents would be equal to each other, and current is simply V over R. So the voltage source divided by the total resistance will give you the total current, which is equal throughout the circuit. Once you have that current, and remember the current's the same throughout, you can solve for all the voltage drops. Again, using Ohm's law, V equals I times R, the total current times whatever resistor value you're trying to find the voltage across gives you the voltage for that resistor. Last part they usually have you solve for is to solve for power. You can use any power formula you want, right? Because by this point we've solved for the currents, we know the voltage, we know all the voltage drops, and we know all the resistance values. So you can use any formula you want to solve for power. I always like to use V times I. The only trick with power is you're finding the power for whatever you're going to use the V and the I for that particular thing that you're trying to solve power for. So you notice for total power, I'm using the total voltage and the total current. For each of the individual powers, I'm going to use the current through that resistor, which happens to be equal because it's a series circuit, multiplied by the voltage drop across that resistor. That will give us the power across that particular resistor. Right? Power is essentially just a measure of the heat, right? A resistor opposes current flow, and that change of energy creates heat. Physically, the bigger the resistor is, the more power it can absorb, the more heat that it can dissipate. Last thing I'll point out to you is Kirchhoff's voltage law. Kirchhoff's voltage law basically says, you can say it one of two ways. Either the sum of the drops equals the source. That's one way you can say Kirchhoff's voltage law. So around any closed loop, you add the drops together, it equals the source voltage. The other way you can say it is the algebraic sum around a closed loop is equal to 0. So if we were to look back at our schematic, right, the voltage drops would be plus minus, plus minus, plus minus, plus minus. So if we, again, drove around our little electron car, we would have a negative value, a positive value, a positive, a positive, a positive, and we get back to the place we started. So these added together, subtracted from this, equal 0 algebraically. So there you go. You know everything there is to know about series resistive circuits.